Welcome back. I think you're going to like this lesson. We've been working with the definition of derivative and using limits to find the slope of a graph. And I kind of hinted a couple lessons ago that I might show you a shortcut. Well, this is the time. First shortcut is called the constant rule. This d dx, that means derivative. So if you're taking the derivative of a constant, the slope is 0. Why is that? Let's take y equals 5. That's literally just the line y equals 5. All of these are just lines y equals 0, y equals -3. They're lines at the height of whatever the constant is, yeah? And what's the slope of a horizontal line? 0. Always. So anytime you're taking the derivative of a constant, the answer is 0. The single variable rule. Now we're just taking the derivative of just a variable hanging out by itself. And if you take the derivative of just a variable, the answer is 1. Because y equals just a variable is the line y equals x. And the slope of that line is 1. It doesn't stay this easy, but it still is better than using the whole limit process. Let me show you why these shortcuts are better. Do you remember Jim? Jim is here when I need you to pay attention to the math and I don't want you taking notes because I really want you to see what's going on. So sit back, put your pencil down, but pay attention. We're going to use the limit process of the derivative to find the general form of the derivative for 2x squared minus 3x. That looks terrible. So the derivative of f of x, all right, is the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're going to have to expand this, the x plus h squared, and then we're going to have to distribute the 3 through. Ay, ay, ay. It gets better from here, though. We can start canceling out like terms. Then we'll factor out an h and cancel that out. And then finally, we can take the limit as h approaches 0 and just stick 0 in for h. And we get 4x minus 3. It's kind of painful to go through all of that algebra. Let's do one more. Same thing, but our function is x squared minus x. To take the derivative of a function, we take the limit as h approaches 0 of f of x plus h minus f of x all over h. This x plus h has to be squared, so we have to expand that. Then cancel out like terms, factor out an h, cancel that sucker, plug in 0 for h, and we finally have 2x minus 1. That's the long way. What's the short way? So I just went through two functions and found the derivatives of each. So if you look at the top function here, and you get to the derivative, look at the top function on the right, and get to the derivative. Do you see any patterns? Watch this. If we take the exponent and multiply it by the coefficient, 2 times 2 is 4. And then we take the exponent and decrease the power by 1. So 2 minus 1 is 1. And then for the second term, basically this is x to the power of 1, right? So 1 times 3 is 3. And then 1 minus 1, decrease the power just by 1. It's 3 times x to the 0. And anything to the 0 power is just 1. So 4x minus 3, that's the derivative. Same thing worked on this right side function here. So the exponent comes forward and then drop the power by 1. The exponent for x, which is just 1, comes forward and then drop the power by 1. That is so much faster. Let's practice some. This is called the power rule. Here's what it looks like. And so here's the exponent n, and notice it just came to the front and then we subtracted 1 from it. So 4 is the exponent. We're going to bring it forward and then subtract 1 from it. 4x cubed. The 6 is the exponent. Comes forward, subtract 1, 6t to the 5th. Now, if there's a constant hanging out in the front here, that's okay. When you bring the 7 forward, you just multiply it times the constant. So 21x to the 6th and 20x to the 3rd. Mixing it all up for you, what is the derivative of y equals 7? That's the line, y equals 7. The slope of that is 0. F of t equals t. That's basically the line y equals x. The slope of that, or the derivative of that, is 1. Okay, y equals 3t. Well, we have a hidden exponent here of 1. So if we bring that forward, 1 times 3 is 3. And then t to the 0 is kind of hiding there. And then g of x equals x squared. So the 2 comes forward, drop the exponent by 1. Oh, well, these don't look pretty at all. But a lot of what we have to do in calculus is rewrite some things to make it easier to work with. So when you see a radical, rewrite the radical as a fractional exponent. Now we're good to go. We're going to bring the exponent forward and subtract 1. What do you do when this whole thing is a fraction? Well, if you have an exponent on the bottom, that's a negative exponent. And now we're doing the general power rule again. So bring the negative 2 forward, subtract 1. This one is just regular. It's got a fraction as a coefficient, but that's okay. Multiply that by 5, subtract 1 from 5. Number 8 looks especially terrible, doesn't it? Drop down here with me for a second and let's look at the cube root of x squared. If I make that a fractional exponent, that's the same thing as x to the 2/3. And x to the 2/3 is on the bottom of the fraction. So actually, that's going to be a negative exponent. So if I rewrite that g of x, it's 1/2 x to the negative 2/3. And now I do the general power rule. So I take this negative 2/3, multiply it times 1/2, and then subtract 3/3 from 2/3. Now, cool thing about calculus is you can stop here. I understand that negative 2/6 is the same thing as negative 1/3, but you don't have to reduce that. Just leave it, just stop right here. Sum and difference rule, this just says if you're taking the derivative of two functions being added together, just take the derivative of each of them separately. This comes in really handy when you have a polynomial, because if you think about it, this f of x here is a bunch of little tiny functions combined together. So all we're going to do is take the derivative of each of them separately. Where'd that 7 go? Well, the derivative of 7 is 0. So same thing for this next one. You just take the derivative of each of the components separately. 5 times 2/5 is 2. Drop the 5 by 1. 4 times 5 is 20. Drop the 4 by 1. 2 times 3 is 6. Drop the 2 by 1. And the derivative of negative 1 is just 0. You don't have to write that. So pause the video for a minute and try these on your own. Make these radicals into fractional exponents. Make this x into a negative exponent. See what you can do with it. How'd you do? I'll show you what I got. X to the 1/3 minus 5x to the 1/2. Just rewrote it and then took the derivative of each of those. And then for the y equals, we already had fractional exponents here, but I rewrote the x on the bottom as an x to the negative 1 and then took the derivative of each of those. Now, where did 4 over x squared come from? Let's slow roll that down here. So 4x to the negative 1. So the negative 1 comes forward. That becomes a negative 4. And then if you subtract 1 from this, you get 4x to the negative 2. Aha. That's the same thing as negative 4 over x squared. And you could leave it as negative 4 over x squared, or you could leave it as 4x to the negative 2. Either one of these forms is totally acceptable. Oh, the derivatives of sine and cosine. You need to memorize these. The derivative of sine is cosine. The derivative of cosine is negative sine. And Jim's here, so I'm going to walk you through the derivative of sine of x the long way. You ready for this? I'm going to go fast, so you can pause it if you want to, but I just want you to see the magic behind the scenes. Okay. Derivative of sine of x. The limit as h approaches 0 of f of x plus h, right, minus f of x all over h. There's no expansion to be done right there, but I can use an angle addition identity on this one. So sine of x plus h, do you remember this from pre-calc? Can turn into sine x cosine h plus cosine x sine of h. And then here's my f of x. Wow. And then I'm going to kind of put sine of x cosine h with sine of x and keep this fellow by itself. I'm going to rearrange it a little bit. Okay. Then I'm going to separate these out into two separate guys. Now, do you remember when we talked about special limits and the squeeze theorem? And we determined that sine of x over x was 1. And then we're supposed to remember 1 minus cosine of x over x equals 0. So sine of x over x, that's hiding right there, that's 1. 1 minus cosine h over h, right there, the limit as h approaches 0 is 0. So really, I'm stuck with cosine of x times 1. There's no h in there to plug in 0 for, so it's just cosine of x. Don't worry about if you would have come up with that. All you have to know is derivative of sine x is cosine x. Derivative of cosine x is negative sine x. The derivative of e to the x is awesome. Derivative of e to the x is e to the x. Yay! And the derivative of ln of x is 1 over x. You just have to memorize those. Putting it all together, find the derivative of each function. So y equals 2 sine x, the derivative of that is y equals 2 cosine x. Y equals sine x over 2. Maybe it's easier to see if you say 1/2 sine x. So the derivative of that is 1/2 cosine x. X plus cosine x, so we have to take the derivative of each of those separately. So the derivative of x is 1, derivative of cosine x is negative sine x. 3e to the x, the derivative is 3e to the x. I love those. X squared plus e to the x. So we're going to take the derivative of each of those separately. So we'll use the power rule on x squared, and it's 2x plus e to the x. Number 14, take each of these separately. Derivative of sine x is cosine x. Derivative of e to the x is e to the x. Couple more. These are a little bit tricky because it's got natural logs. We learned that the derivative of the natural log of x is 1 over x. But you cannot say that the derivative of ln x cubed is 1 over x cubed. That's not a thing. What we have to do is use our log rules to rearrange this a little bit, and then you'll see where it goes. So for log rules, that exponent can come forward to the front. So really, I'm taking the derivative of 3 ln x. And now the derivative of ln x is 1 over x. So we've got the derivative is 3 over x. This guy here, we've got a multiplication. So we can split that into ln x squared plus ln e to the x. And then these exponents can pop to the front. Yeah. So ln of e, what's the ln of e? It's 1. So really, we're just taking the derivative of 2 ln x plus x, which is 2 over x plus 1. Ln of x minus 1 over x. That's confusing because 1 over x is the derivative of ln of x. But they're two separate functions, so we need to deal with them separately. So let's rewrite that. We've got ln x minus x to the negative 1. The derivative of that is 1 over x plus 1 over x squared. Again, where did this 1 over x squared come from? If you have negative x to the negative 1, the negative 1 comes forward, so now it's positive, and then drop the exponent by 1. So negative 1 minus 1 is negative 2. And x to the negative 2 is 1 over x squared. Either of these forms is acceptable. Number 18, we've got a division here with a log, so we can separate that by subtraction. Now this, we've got ln of 2 times e to the x. So we're actually going to break this guy up. That's two functions being multiplied. So that can be a log addition problem. And then look what we have here again. Ln of e is 1. Ln of 2, that's actually just a number. It's a constant. So we've got a constant plus x times 1 minus, a constant minus ln of x. So the derivative of a constant is 0, derivative of x is 1, the derivative of this constant is 0, and the derivative of ln of x is 1 over x. And that simplifies to 1 minus 1 over x. Now, admittedly, number 18 looks a bit scary, but one step at a time. You know this. You can totally do it. So we will stop there for now, and I'll see you in the next lesson. Thank you for hanging in there with me.